Welcome to the final week of the first part of the course on reliable distributed algorithm. This week is devoted to the problem of single value consensus. In consensus, the processes propose values and they all have to agree on one of these values. Solving various flavors of consensus is key to solve many problems in distributed computing. As examples, we have total order broadcast, sometimes called atomic broadcast, atomic commit, used in databases, terminating reliable broadcast, dynamic group membership, and finally, shared memory with stronger models, where you allow operations like compare and swap, for example. We define the single value consensus problem both for regular and uniform consensus. Then we describe hierarchical consensus, an algorithm that solves regular consensus in the fail-stop model, where we have access to a perfect failure detector, and prove the correctness of the algorithm. This algorithm takes n rounds, where n is a number of processes. We end up this unit by describing an equivalent algorithm in a control-oriented programming model instead of the event-based model. We then modify the algorithm to work for uniform consensus in the fail-stop model. We show that uniform consensus is solvable with a weaker failure detector than P using the same algorithm by replacing P with a strong detector, S, that behaves roughly as P but is accurate with respect to one process. Finally, we show that we cannot solve the uniform consensus problem using an eventually perfect failure detector if half or more of the processes can crash. In the next lecture, we show how uniform consensus is solved efficiently using omega, the eventual leader election abstraction.